Hello, my name is William. In this video, I will explain all questions from the Uniform Mid-Unit assignment. Every question involves trigonometry modeling, where we use sine or cosine function to represent periodic patterns. I will explain how I create the graph from the amplitude, period, and translation, and then build the final trigonometric equations. First of all, I would like to explain the question number 4. What I need to create a trigonometric model from the tables of values. First, I look at the table, the A value go from 1 to 12, um, and each value has corresponding Y value. These values appear to increase and decrease in a repeating pattern, which suggests that the data can be modeled using a trigonometric function such as sine or cosine. In the question, I will use a cosine function because cosine functions are commonly used to model periodic patterns when the graph stands near a maximum or minimum value. The general form of the cosine equation I will use is y equal to a into cos into k into a minus t plus c. In the equation, a represent the amplitude, k controls the period, t represent the horizontal shape, and c represent the vertical translation or midline. First, I find the maximum value in the table. From the table, the maximum value is 21 and the minimum value is minus 24. This value tells me how far the graph goes up and down. This value so next I calculate the amplitude, which has the distance between the maximum and minimum. The formula for the amplitude is A equal to maximum minus minimum over 2. So substitute the value. So the amplitude of the model is 22.5. Next, I find the midline. Sorry, I find the period. Um, looking at the table, the pattern repeat every 12 unit or every 12 unit or 8. So the period is 12. The formula for the period is 2 pi over k. So the value of k is pi over 6. Next, I determine the horizontal shape, which tells me where the cosine graph stands. From the table, the minimum value occur 7. 1 equal to the minimum value. The maximum value occur 1 equal to 7. So the the horizontal. So the value of t equal to 7. Next, I determine. I determine the midline of the graph. The formula of midline is maximum plus minimum over 2. So substitute the values. So the value of midline of the graph is y equal to minus 1.5. Um, so the final equation becomes y equal to 22.5 into cos pi over 6 bracket a minus 7 bracket minus 1.5. So we can check the answer. 1 equal to 1, 1 equal to 1, and y equal to 22.5 cos a over pi over 6 bracket by 1 minus 7 bracket minus 1.5. The answer will be minus 24. So from there, the answer match the table from the table. Yeah, yes. So, and then I will continue the question number 2. In the question, I am given a table that shows the relationship between time in seconds and age in meters. The value in the table are at 0 second, the height is 1 meter, at 6 second, the height is 6 meter, at 12 seconds, the height is 11 meter. At 18 seconds, the height is also 6 meter. And at 24 seconds, the height is 1 meter again. Uh, 1 meter again. When I look at these values, I noted that the height first increased um, and then reached a maximum value. Height, height decreased again. After 24 seconds, the pattern would repeat again. This this tidal pattern is called a periodic pattern because it repeats over time. Periodic patterns are often modeled using trigonometric value and trigonometric functions such as sine or cosine because the graph starts at a lower value, rise to a maximum, and then can pass down smoothly. It can be modeled using a cosine function. Next, I plot the data point from the table onto a graph. The A is represent a time and the Y is represent height. After plotting the points, I connected them with the curve. The shape of the color like paddle cosine wave, which confirm that a trigonometric model is appropriate. That motion is similar to something like a Ferris wheel, where the rider moves up and down in a smooth circular motion. Next, I determine the amplitude of the function. The amplitude takes as how far the graph moves above or below the midline. So the formula for amplitude is A equal to maximum minus over 2. From the table, the maximum height is 11 and the minimum height is 1. So the answer of amplitude will be 5. Now I find the midline which represents the center of graph. The formula of the midline is c equal to maximum plus minimum over 2. So now substitute the value and the answer of the midline will be 6. Next, I determine the period, which is the time required for one full cycle of the motion. From the table, the height start 1 meter at 0 seconds and return 1 meter again at 24 seconds. This means the motion repeat every 24 seconds. So the period is 24 seconds. And the formula for the period is t equal to 2 pi over k. Um, Substitute the period and the value of k it will be pi over 12. Now next I determine the horizontal translation which tells us where the graph is shifted. From the graph, the maximum height occurs at 12 seconds. This means the horizontal shifts to 12 units. Now I substitute all value into the cosine function. So the trigonometric equation becomes a or t equal to 5 into cos into pi over 12 into t minus 12 plus 6. The equation represents the height of the rider over time. Finally, I check the equation using a value from the table first. 20 equal to 12 seconds. Um, 2 equal to 12 seconds. The height should be the maximum value of 11 meter. Uh, Substitute and then 1 t equal to 0, a 0 equal to minus 5 cos into pi over 12 into 0 plus 6. So the answer will be 1 meter. So this match from the table. So this match from the table and 1 a equal to 6, we will get a 6 meter. So they also match the table because the calculated values match the data and the equation correctly models the motion. Now let me continue number 3. In this problem, I will explain how to model height using a cosine function and use it to determine when a ball can talk. First, I needed to determine the amplitude at the midline of the function. The amplitude represent how the distance between the maximum height and the minimum height. From the data, the maximum height is 17.3 meters and the minimum height is 4.5 meters. So I calculate the amplitude using maximum minus minimum over 2. So now substitute the value and the SR wave is 0.4. Next, I calculate the midline which represent the average tide height. To find it, I take the average of the minimum maximum value and minimum value. So the formula of midline will be maximum plus minimum over 2. Now substitute the value and the answer will get 10.9 meters. So that tide oscillate, oscillate, oscillate around 10.9 meters. Next, I needed to determine the period, which time it takes for the tide to complete one full cycle. From the data, the low tide occur at 203 and the high tide occur at 21. First, I convert these time into decimal hours. So 203 began 2.13 hours and 821 began 8.35 hours. Then I calculate the time between the low and high tide. So 8.35 minus 2.13, so the answer will be 6.22 hours. Since moving from low tide to high tide represent hydro a cycle. This means the full period is twice. The full period is twice that time. So the full period is t equal to 2 into 6.22. So the answer will be 12.44 hours. Um, and then we will find a value using a 2 pi over t. Um, so now substitute the value and value. So we will get a 28.93 value for A. Um, so if t equal to 0, the function needs a maximum at 8.35. So t equal to 8.35. So final equation we will get a dot t equal to 6.4 cos into pi over 6.22 into t minus 8.35 8.35 plus 10.9. Um, Next, I use the model to calculate the tide height at 11:30. First, I convert 11:30 to decimal hours, which so the answer will be 11 point hours. Now substitute into the equation 8.1115 equal to 7.4 cos into 28.93 into 11.5 minus 8.35 plus 10.9. So the answer will be say 10.8 meter. Next, I calculate a table of value and a graph of function. From the graph, we can see the tide rise from the minimum value 4.5 meter 4.5 meter and then the 4.5 meter which as maximum of 70.3 meters and then decrease again. And this shape match the expert cosine wave pattern of ocean tide. And then finally, I needed to determine when the boat can dock. The boat required the tide height to be 12 meters. So I look where the graph intersect a dot t equal to 12. From the calculation, this occurs as approximately t equal to 5.58 hours and t equal to 11.12 hours. So we need to convert in these back to regular time. So 5.58 hours will be 535. 11.12 will be 11:07. So this means the boat can dock at approximately 535 hours and leave at approximately 11:07. So that's all that's all my video. Thank you for watching my video. See you in the next video. Bye bye.